Hello, my name is Ben Holzworth, and this is my presentation for Lab 1 Constant Velocity in Physics 2211 at Georgia Tech. This is a brief table of contents. So in this lab, we will be examining an object moving at constant velocity, in this case, a roll of tape, and comparing our results of the observation to a computational model modeling constant velocity. So a few notes to start. Constant velocity means that the object will have a net force of 0 acting on it in any direction. This is in accordance with Newton's first law, which states that any object that does not have an external force acting on it will continue to move at its current velocity or remain still if it is not in motion. And this is a formula used for final velocity. So in this case, since there is no net force, this formula will just equal the initial velocity. Hence, there's a constant velocity across the entire lab. This is a brief force diagram. So this circle represents the tape roll. The normal force and force due to gravity are obviously acting on any object that is resting on a surface on Earth, but they cancel out, so the net force in the vertical is 0. And this is a diagram of tape already in motion, so we are assuming that there is no applied force at this moment, and we are also assuming for this lab that there is no air resistance or friction. So the net force along the horizontal is also 0. This is a video. This is what we used to observe the motion of the object. It was put into Tracker, which was used to track the object's motion. This is just a simple video. So as you can see, a force was applied at the beginning, and then there was no forces acting on the tape besides, I guess, friction, but we're ignoring that in this case. So this is a graph that was constructed using the data from Tracker, and as you can see, it is almost linear, but because this is in real life and there is in fact a small amount of friction, the tape roll does start to slow down near the end of its motion. This is our predicted model. So we use GlowScript. This is a small excerpt of the code. You can see we had 0 net force. The initial position is actually not given here, but we gave the object an initial velocity that was calculated using the data from Tracker, and you can see that this is really a linear version of the graph that we saw earlier. Here are the two side by side, so we can see that the prediction was fairly accurate, except for the fact that since we assumed that friction was not existing in this case, but it did in fact exist in the observed instance, the observed graph is not actually linear and slows down near the end. Some further exploration: if the axes were flipped, then the graph we saw would be flipped, but it would be the same line, just in the negative, so it would not have impacted the distance traveled or the speed. Just technically its velocity would have been different, but it's not very relevant. If we're assuming that the forces at play on the roll of tape, after the initial force was applied to it, there would have been some frictional force resisting it, which is why it slowed down in the end, and the normal force and gravitational force would have canceled out to 0. But while the roll of tape was in essentially the middle of its motion, it likely had a net force of about 0.